These plasma wave sounds were recorded by Voyager 1 as it passed by the planet Jupiter in March. The second spacecraft, Voyager 2, will make its closest encounter on July 9th.
For me personally, this is the most exciting mission that I've ever worked with. And I think probably it's going to be one of the most scientifically productive of the planetary missions.
Planetary astronomer Dr. Bradford Smith from the University of Arizona is imaging team leader for the Voyager mission to the planets.
It's particularly exciting because we're really going into the unknown. I think this is the first time since Mariner 4 that we were less prepared for what we have finally seen, in that we knew essentially nothing about the surface properties of the Galilean satellites. We knew very, very little about the sort of detail and dynamics that we'd be seeing in the Jovian atmosphere. So it was really a first look, and a very, very good first look at that, and that always makes a mission exciting.
The planet Jupiter has evolved at a slower rate because of its great distance from the Sun. Studying it close up and in detail gives scientists a chance to see conditions as they may have existed very early in the formation of our solar system, including the Earth. Again, planetary astronomer Dr. Brad Smith.
Jupiter is, first of all, a large ball of gas. It may, at its center, have a silicate core. That core may be surrounded by metallic or liquid hydrogen. But once one gets away from that inner core, which Voyager certainly cannot observe, we have a gaseous atmosphere. What Voyager is able to see is the very top of that atmosphere where the clouds form, the so-called tropopause. And we may be seeing individual layers of clouds, the highest most being composed of crystals of ammonia, that is ammonia ice, and these clouds are analogous to the high cirrus clouds that form in the Earth's atmosphere.
Last March, as Voyager 1 arced past Jupiter on its way to Saturn, its cameras recorded pictures of the 4 largest satellites, or moons, that orbit the huge Jovian planet: Io, Europa, Ganymede, and Callisto. The bright colors of Io are believed to consist of mixtures of salts and sulfur brought to the surface by volcanic activity and other processes. An enormous volcanic explosion was recorded about 11 hours before Voyager 1's closest approach to Io, that showed solid material being thrown to an altitude of 100 miles. The most unusual features of the satellite Europa are the long lines which cross the surface in various directions, some over 1,000 kilometers long and 300 kilometers wide. Ganymede, the largest satellite, is probably a mixture of rock and ice. It has impact rays similar to ones on our own moon. Numerous craters that appear on the icy surface of Callisto lead scientists to believe its surface is the oldest of the 4 satellites of Jupiter, possibly 4 to 4.5 billion years. Voyager 2's flight path will take it by Callisto from a different angle and much closer to the large moons Ganymede and Europa. The Voyagers, returning spectacular pictures and important new information about our neighbors in the solar system.